Okay, hello A and P friends. Let's do the endocrine system. Yay, endocrine system. Okay, what are we gonna do? We are going to review endocrine versus exocrine glands really quickly, and then we are going to get into the G's. Endocrine glands release hormones directly into the bloodstream without a duct. So this is what we've been talking about this whole time. Should not be new information for you, right? This is all of the things that we've been talking about. We've been talking about your hypothalamus sending a signal to AMP-PIT to release the releasing hormones, and then AMP-PIT sends those out into the bloodstream, right? To hopefully find a gland that has the proper acceptance of that, right? Okay, so just not out into the bloodstream for everyone, but only those that have receptors, okay? Endocrine glands out into the bloodstream. You can see this picture here. Into the capillaries. Into the capillaries we go. Hormones are secreted directly into the blood. Versus an exocrine gland. These are like your tear ducts. These are glands that secrete substances like sweat, tears, digestive enzymes onto your body's surface or into an internal cavity. The key differences between these things to remember: use of ducts. Is there a tear duct? Is there some kind of a duct? The type of secretion. Is it hormones? Like the endocrine glands are going to release hormones versus your exocrine glands are going to release sweat or mucus. And what is the destination of this going to be? Is it going to be directly into the bloodstream like our friends, the endocrine glands, or is it going to be onto your body surface or one of your body cavities? Okay, that's a review of endocrine and exocrine glands. Next up, the pancreas. Just as, again, I think we talked about this, but I had to start somewhere. So we are talking about the pancreas because it has both exocrine and endocrine glands. Very exciting. Endocrine and exocrine glands. So exocrine glands, what do? They produce things from a duct. They are going to produce digestive enzymes directly into your stomach, right? Yay. It's a bile duct. See how I use the word duct? Because you know it's an exocrine gland and it's going to have a duct and it's going to produce bile, and that bile is going to go directly into your stomach. Or other digestive enzymes, also brought to you by the pancreas. There are other pancreatic ducts, so you know those are exocrine glands, and they secrete things like bicarbonate. They neutralize stomach acid with the bicarbonate, okay? So those are your exocrine glands in your pancreas. Your endocrine glands, okay? Yes, insulin. Do you remember the really awesome feedback loop that we talked about? And I drew because I'm so good at drawing. Yes, right? That is sealed into your mind because of my excellent drawing. So we produce insulin, right? We produce insulin when we eat a cupcake, or really when we eat anything. You have some extra glucose, so you've got insulin that makes that into glycogen. You have glucagon, which is an enzyme that breaks down your glycogen and makes it into glucose. And you have somatostatin. All those regulate your blood glucose levels with a super fun feedback loop. Here's a little quiz. Exocrine versus endocrine glands. Feel free to pause the video and see if you can figure out which ones are the endocrine and which ones are the exocrine. Pretty simple. These have ducts. These are all little ducts here. So these are your exocrine glands. These are your endocrine glands. Okay, we got hypothalamus and AMP-PIT and post-PIT here. You got a thyroid. You got a mammary gland. Oh, you got a mammary gland over here. And so you have all kinds of fun stuff going on. Okay, so feel free to look at those again. Here is an overview. You've got all these ducts: mouth, saliva, skin, sweat glands, enzymes in your stomach. We just talked about the pancreas. Breast glands, liver produces the bile duct. Okay, pancreas juices are all exocrine glands. Okay, let's talk about the pancreatic hormones. You have alpha cells. The alpha cells are going to release glucagon. Glucagon is the enzyme that's going to be released between meals when the glucose level falls. And it's going to raise your blood glucose level. How? At 3:30 when you are out of glucose. How is that going to happen? It's going to go to your liver. It's going to stimulate gluconeogenesis and glycogenolysis. I'm not even kidding with the G's. Don't worry, we have a slide. We have a slide. It's coming. So it's going to basically stimulate gluconeogenesis and you're going to stimulate fat catabolism, okay? This is in between meals. Your insulin, this is your beta cells are going to happen. This is during and after a meal when your glucose and your levels are rising, and this stimulates cells to absorb these nutrients and store or metabolize them, and it will lower your blood sugar, okay? This promotes the synthesis of glycogen. Glycogen is the storage. Glucagon is the enzyme. I'm going to say that about 25 times. This is going to promote the synthesis of glycogen. Okay, somatostatin. This is going to partially suppress secretions of glucagon. Glucagon is the enzyme, and insulin is the enzyme. Okay, this is going to inhibit nutrient digestion and absorption, which prolongs nutrient absorption. Okay, also, you do have some polypeptides up here for vagal stimulation of the pancreas after a meal. So all of that happens in your pancreas. So cool. I feel like the pancreas is often overlooked as a very cool organ. Okay, the G's. I told you, get a piece of paper or just, right? There's a bunch of them. Glycogen. This is the carbohydrate. Okay? Not to be confused with glucagon, which is the hormone secreted from the pancreas. The hormone secreted from the pancreas is what's going to make the carbohydrate glycogen. Glucagon is the hormone, glycogen is the carbohydrate. Okay? So your glucagon, which is the carbohydrate, glycogen, it's a carbohydrate that it's made when you have available energy storage, like right after a meal, you have plenty of energy. So your body's like, hey, we have enough. We're going to go store some in as glycogen. Glucagon is the hormone that says, hey, you have enough. Go store some. Okay? Glucagon is the hormone secreted by the pancreas. It function is increases blood glucose level. It's released when blood sugar is low, and it stimulates the liver to break down glycogen into glucose. Okay? Glycogen is the carbohydrate. Glucagon is what breaks her down. Okay? Now, again, insulin increases glycogenesis, the making genesis of glycogen. Okay? Insulin is going to make the glycogen. It also increases lipogenesis and decreases lipolysis, but I'm mostly worried just about the glycogenesis, okay? When blood sugar levels get too high, right? It's too high. Like you just ate a dozen Krispy Kreme donuts because they were warm and you could not stop. The pancreas releases insulin into your blood, and they're like, okay, let's do this thing, right? Insulin is released, which triggers glucose to be converted to glycogen in the liver. Okay? Glucose converted to glycogen happens through glycolysis when insulin tells you it's time. So insulin is like, let's do some glycolysis. Let's take glucose and make it into glycogen. Yes? Flow chart maybe for that? Glucagon. This is the enzyme that makes glycogenolysis. You thought I was kidding with all the G's, okay? We're just going to take the top one. So, when blood glucose levels get too low, when blood glucose levels get too low, 330, the pancreas releases glucagon. This is the enzyme into the blood. What does the enzyme do? It triggers glycogen to be converted back to glucose so that you have an available storage, right? It's almost like a feedback loop. It is a feedback loop, right? Yes. We drew it on the board. Okay. Glycolysis. I feel like should be mentioned here because you're going to be like, isn't there another G word? Glycolysis. Yes. This is the thing you learned. Cellular respiration. Yes. Right? This is taking a glucose molecule and making it into ATP. That's glycolysis. Had to be said. Okay. Glycogenesis. The formation of glycogen from glucose. Brought to you by insulin. Insulin says, okay, we just ate a dozen Krispy Kremes. We got some extra glucose. Let's put that into glycogen. Okay, stores the excess glucose for future use, mainly in the liver and the skeletal muscles, after consuming a carbohydrate-rich meal. Stimulated by insulin. Yes? gluconeogenesis. This is the production of glucose from a non-carbohydrate source, such as lactate, pyruvate, glycerol, and amino acids. This is when your dietary intake is extremely low. This is not just the 330 one. We're going to get to that one. Glyconeogenesis is when you have fasted, when you have had a really hard practice, when you have run a marathon, when your glycogen reserves are gone. And this is activated by glucagon and suppressed by insulin. Okay, so gluconeogenesis. This is taking it directly from your lactate. This is like, it's bad. You have not carb loaded enough. Glycogenolysis. This is the breakdown of glycogen, your stored glucose, your starch flour of storage. This is the breakdown of glycogen into smaller units of glucose, the two forms of glucose. This is your 330 process, glycogenolysis. Okay, this is to release the glucose from your stored glycogen to meet immediate energy demands. Like you're done. At 3:30, the iced coffee has worn off and you need some energy. The stored glycogen molecule itself is what causes this when it occurs. When glucose levels drop, but glycogen stores remain. So you've not been fasting, you ate a decent lunch, this will kick in. Okay, after a normal meal or during light exercise. This is stimulated by glucagon. Okay, you need to figure those out because that's going to kill you. I have every visual I can give you. And at some point, you just have to figure it out. So you have glycolysis. This breaks down glucose. Okay, breaking down glucose. So it's going to make your glucose. Gluconeogenesis makes new glucose from like your muscles or your lactates. This is happening when you are running a marathon. Glycogenolysis. This is just breaking down your glycogen, your 330 situation. Glycogenesis. This is making new glycogen after you eat a dozen Krispy Kreme donuts. Okay? Yes, yes. Glycolysis. This is like the old cellular respiration situation, right? It breaks down the glucose into energy. Yes, yes. Okay, we have it. Okay, again, I've given you all of these. The process of breakdown of glycogen to glucose. This is the opposite. Glycogenesis is the process of glucose to glycogen. Okay, here's our loop. To remember our super fun loop, we ate donuts. The pancreas releases insulin. The liver takes up the glucose and stores it as glycogen. Yes, yes. Okay, and then you're back to your homeostasis, 90 milligrams, okay? Or it's 330 and you're done. Your blood glucose level drops. Your pancreas releases glucagon, which is the enzyme. That enzyme breaks down your glycogen back into glucose, and we're back. Okay, this doesn't include the glyconeogenesis because that's when you're fasting. Okay, another one. I mean, I'm trying to give you every possible. Here's your normal glucose level. Here's your increased glucose, right? And here's it goes into your cells. It also gets stored as glycogen into your liver and you're back to normal. You decrease your glucose. Your pancreas sends out these alpha cells to release glucagon and it makes your glucose again so that you can return to normal levels. Yes? Hyperglycemic versus hypoglycemic. So these are the actual hormones. Hyperglycemic hormones, glucagon, some cortisol. These are just the ones to know, right? Absorption from the GI tract starts to glucose, glycogenolysis in the liver, sources of blood glucose, right? These are just the, hyperglycemic hormones. Hypoglycemic hormones, glycolysis. Okay. I'm going to make another video and we're going to start on the kidneys.